West Virginia, Blue Ridge Mountains, Shenandoah River. Life is old here, older than the trees, younger than the mountains, growing like a breeze. Take me home, country road, to the place I belong, West Virginia, Mountain Mama, take me home, country road.
Hello everybody, welcome to this edition of Video Notes for Mr. Flugum's AP Chemistry class. That's right, you guys, this is for AP Chem. And we're going to just review some electron configurations, all right, you guys? And so, this isn't necessarily a required one, but it's here for your help and education, all right? So let's go ahead and get started. All right, so here's the deal, folks. When we talk about electrons, remember electrons are organized into energy levels or orbitals, right? And then each level has different sublevels to it. Those levels are S, P, D, and F, right? And here's the deal. You always fill electrons from the bottom up, so from lowest energy to highest energy, right? And there is a format in order to do that. And so, I've got that on the next slide here. Check it out. All right, so just some quick review, you guys. What does a period of an element tell you about the electron orbitals? So remember this, right? Okay, when we look at periods on the periodic table, right? Here's period 1, 2, 3, and going across. Remember, the period tells you the level of the highest electrons, right? So that means this, elements in period 3 here, okay, their electrons are in the third energy level. That would be the highest energy level for them, and so on. So that's something important, right? And then, as we do this, right, S, P, and D blocks, remember this, right? We've got S block is these two rows right over here, okay? You've got the D block, that is the center, the transition metals, the P block over here, and then remember the F block is at the bottom there, right? Okay, and then how do we use this chart over here on the right? So this chart right here shows us what order to fill the electron levels in, right? And the big key is this, okay? The big key is, if you notice, it goes 3P, 4S, right? And then after 4S, we go 3D, okay? So the D levels always lag one level behind the S and P levels, all right? Don't worry too much about the Fs. They're there. This chart can help you with those, but we won't be dealing with those very much, all right? So that's a little review about filling electron levels, okay? All right, so remember this, right? When we fill levels, we fill from the bottom up. So we've got hydrogen, okay? Hydrogen is 1 electron. So we do this, right? We say, okay, 1s1, okay? So this is our energy level is 1. Our sublevel is S, okay? And that S orbital has 1 electron in it, the number of electrons, right? Okay. Now when we get to helium, that has 2 electrons, right? So those 2 electrons go in the S orbital, right? Because remember, S can hold up to 2 electrons in the S orbital. So now, how do we do lithium? Well, lithium has 3 electrons, right? It's element number 3. And it also is this. It's in the second period on the periodic table, right? So that means this, that its highest level electron will be in level 2. So for lithium, I do this, right? 1s2, because S can only hold 2 electrons, right? And then I've got level 2, S1. So fill from the bottom up until you run out of electrons. Just to keep going with the trend here, we've got beryllium, right? Beryllium has 4 electrons, and it's in the second period. So that means its highest electron will be in level 2. So I'm going to go like this: 1s2, 2s2. All right, folks, so here are the rest of the elements in the second and the beginning of the third period. And it shows you here not only their long hand, right, all of the electrons, but it also shows you your noble gas shortcut. So with the noble gas shortcut, this is a way for us to do these shorthand. So basically you use the noble gas from the period above, put that in square brackets, and then work from there in order to write out the electron configuration. So that's a way we can make this a little bit shorter for ourselves, especially when we get down into those larger elements that have 20 plus electrons. So speaking of larger elements with 20 plus electrons, here's scandium. All right, so if we want to write this out shorthand, that's easy to do. We can go like this. We can go to the third period, which is above scandium, and we can go argon, right, AR, and then we can go like this. So we're in the fourth period for scandium, right, so that must be 4s2, right, and then remember this, after 4s comes 3d, and I'd go 3d1 because it is the first element in the D block there. So if I count my electrons, there are 18 in argon, and then there's 2 more in the 4s, 20, and 1 more in the D. That's 21 electrons. That's how many I need. All right, folks, so let's talk orbital diagrams real quick. Remember, orbital diagrams are not Bohr models, okay? So they're not the circle things like this, okay? Do not do that for Bohr models, all right? What we want is we want this, right? We want to write like this, so put out the orbitals that you're going to deal with, or the sublevels, excuse me. Another word for sublevel is orbital. And then we go like this. We go up arrow, down arrow. Remember, opposite spins in the same electron orbital, right? And we go 2s, like that. So there's 4 electrons. I need 9 altogether for fluorine because it's element number 9. So there's 1, 2, 3, 4. Then I'm going to go like this, right? Remember, fill 1 in each orbital before we start filling. So there's 7, 8, 9. Okay, they should have opposite spins. And remember, there needs to be 1 electron in each sublevel or each orbital before I put a second. All right, if you have more questions about that, let me know. I'll walk it through with you. Okay, we're going to cover this in class, but I'll give you a quick rundown here too. Magnetism, okay? Some things, not just iron, atoms, a lot of atoms can be magnetic, right? Just that they're single atoms, right, that aren't bonded. So here we have diamagnetic atoms. So lone atoms with no unpaired electrons are not attracted to magnetic fields. They are called diamagnetic, okay? So if we look at neon is diamagnetic because if we look at its electron orbital configuration, it has all paired electrons. There are no unpaired electrons. So diamagnetic means no unpaired electrons. And that means single atoms are not attracted to a magnetic field. However, we will find that there are many, many atoms that have unpaired electrons. So paramagnetic atoms, all right, paramagnetic atoms have what's called a magnetic moment, all right? And that means this, lone atoms, so when the atoms are by themselves, not bonded to anything or any other atom, okay, they will be attracted by magnetic fields. Sorry, I didn't mean to cross that out. They'll be attracted to magnetic fields, okay? So that means gaseous carbon, right? That means the atoms are separated from one another. It has 2 unpaired electrons, so it is paramagnetic and will be attracted by a magnetic field when it's in a gaseous state. So paramagnetic, unpaired electrons affected by magnetism have a magnetic moment, okay? If they have all paired electrons, they are diamagnetic. Well, thanks for tuning in, you guys. If you have questions, please let me know, and I will try and help you out. And I hope your day is going well. We'll talk to you later. Bye-bye.